Okay, in this week, we're going to be talking about chapter 6, which is about objects and classes. This is really the main part of Java and its object-oriented programming framework, and the way that Java can leverage encapsulation and isolation and specialization through objects and classes. So we're going to be covering chapter 6 now. Okay. And we're going to be talking about all these topics here. So an object and class is an object which exists in memory and it can perform a certain task. And then there's really two different kind of capabilities with object. Object can store the data, and these are considered the data fields. And then objects can also perform operations. And this is what is known as methods. So far, you've seen a couple of objects so far. You've seen the scanner object for reading input. You've seen the random object for generating random numbers. And you also saw the print writer for writing data to files. And so these kinds of objects are specialized kinds of objects that do specialized things. And it encapsulates that special function within these classes. So where does these objects come from? Okay, so the object actually comes from a class definition. So the class definition is a piece of code that either you write or somebody else has written that can do these specific kinds of methods, and it can handle certain kind of data fields. And you can think of the class as like a sort of like the blueprint or the template of how the object gets created. So when a program's running, it can use the class to create that object in memory using the class. And it can create as many specific kind of classes as needed. And once you create this object from the class, that object is called an instance of the class. And it's often also the verb for it is to instantiate the class. So far, like we said, that we've come across a couple of classes already in this class. So you talked about the scanner object for handling input from the keyboard. So you create a instance of the scanner object, of the scanner class, and you create a scanner object, which is of type keyboard. And then the keyboard variable is just a pointer to the actual scanner object in memory. Same thing with the random number generator. You create you instantiate an object from the random class, and the rand variable is really an address to a rand object in memory. And this is the last thing with the print writer, very similar concept of the two other ones. So in the base Java framework or the Java API, it provides these kinds of objects as part of the default Java API. And there are many more, but the ones that we've so far come across are the scanner, random, and print writer. And you can see the object demo source code that's provided. So what we're going to be doing is writing a class step by step, and we're going to be writing a new class called rectangle. And it's going to have two fields or two attributes. One is length, the other one is width. Okay, it's going to contain a numerical value. And the rectangle class will also have these various methods to set the length, width, and so forth. And you can also get values out of the class, and one of them would be the get area, which is a computational value of the length and width. And then you also should know about the UML diagrams of how UML is used to graphically represent Java classes. So the class name goes in the top, field goes next, and then the methods are listed on the bottom. So these would be the the fields, the name, the attributes, and then the methods. So this is how the rectangle class would look like. The public class. Um, we'll talk about more about the attributes like public and private, so forth. Actually, we covered that in the previous, which is the methods. Um, we're going to go over that again. So when something is specified as public, that means that any code outside of the class can access that. When you see something with a private, that means that only code within that specific class can access the methods or data attributes. So this is how the method signature would look like for uh, a a class method like set length. You would see the access specifier, the return type, the name, and any number of optional parameters. And you can notice here that the static doesn't appear in the method header signature. And that's because we are designing this method so that it works on the instance of the class, so that it can actually be operating on data inside of the instance. Okay, so this is an example of the set length method for the rectangle class. So it's just accepting an input parameter of double type len, and then setting that to the length um, data member or attribute member. And then when we want to actually instantiate an object from the rectangle class, we specify it this way. We provide the object type rectangle on the left side, a variable box, the assignment operator, and then the new operation, and then the name of the class. Okay. And so what box the variable is going to contain is going to contain an address to a piece of memory of the object from the class, from the rectangle class. And then we're going to, this is an example of how we would set a method or call a method off of the object. We use the box variable, and then we say set length or some method name off of the object. And it's going to use the address to get access to the specific data inside of that specific instance. That specific instance, if you back up one slide, that specific instance initially had length and width set to 0 because those were the initial values. And so when you say the set length here, it's actually just setting one of those data members within the object, in this case length, and the other one isn't yet been set. So then we actually write the get length method, and it would look like this. And you just basically return the data member, data attribute of length when you call get length. And actually, this is the example of what the get area method would look like for the rectangle class. And you multiply both length with the width, and you return the result to the caller of the get area method. And because there's this concept of accessor and mutate, and this is just a terminology that's used in the Java programming circles. You can think of accessors as the getters, and you can think of the mutators as the set methods. Or whenever we are just getting data out of the object, those are the accessors. And then whenever we are changing data within the object, those are the mutators. And there's this concept here because we are trying to hide the data within the class. That's why these fields in the class, like the length and the width inside of the object, are private because we don't want it to be directly accessible from code outside of the class. but we do set the methods to get to the specific to get the value of the length or get the value of the width, set those as public so that code outside of the class can get this value or set the values. And as I mentioned here, that the mutators and accessors are often called the getters and setters. So the concept of data hiding is that we're really trying to protect the actual specific private data fields inside the class and only let the access to those data attributes or data fields to be accessed only through the class methods. That way we try to prevent direct access to the data fields without going, but only going it through the public methods. So why is it important that we do some of this data hiding is that sometimes these components like rectangles are not this simple, but they're actually quite complex. And we want to try to prevent too much exposure of what's going on inside the class to a caller outside. There is also a concept of the stale data, and this is when we actually consider the rectangle area, when we compute the length by the width, we actually don't actually want to calculate that and then keep it as another attribute inside of the class. We actually just want to compute it and then just return it. Because if we were to keep the area as another data attribute inside the object, then we would constantly need to maintain the value of that area anytime the width or the length changes. So that's why we want to avoid that kind of stale data. And we rather just compute the data with the method and then return it rather than storing it within the object itself. So this is the example of the get area. You compute the area multiplying the length by the width and then just return it. Not actually keep the value of the area inside of the object. We don't want to do that. That would cause stale data to be kept inside of the object. So this is the UML notation of the various data types and then parameter notations for a class definition. So again, we have the name of the class on the top, any number of data fields or attributes, the next section, the width in this case, and you can see that the minus sign means private, the plus sign means public, and then you can also see that the data types are also visible. Here you can see that the width date attribute is a double, and the set width accepts a double input parameter, and then it returns null. Returns a void. This way it doesn't actually return any data. So this is, again, the additional notes about the notation, putting semicolon between the data attribute name, width, and the colon between the width and then the data type double. More notations about the UML notation is that you show parameters inside the method and you specify the variable name, parameter name like W, and then it being of type double, and you see the colon between the variable parameter name W and the type double. So some parts of the skills you need to know is converting a UML diagram into code. So you do sometimes need to convert a diagram and then put those UML diagrams into code. So this would be then an example of converting that UML diagram into a specific Java code. Okay. This is just a more code completion of that. And then Then it's really now the understanding of the Java class layout convention. So this is something that Java programmers sort of use as a convention, which is the first thing you would see besides the name of the class on the top is the field names that are listed first, and then methods are listed next. Okay? And then um, the various accessors or mutators or setters and getters are typically grouped together. So you'll see the get length and uh, set length sort of grouped together, not spread out too far apart. And that just makes reading the code a lot more easier to understand. And there are some code, I mean, some tools that help doing the layout of that kind of coding. And now is the concept about instance fields and instance methods. Okay, so since we didn't define these methods with static, that meant that all those methods were instance methods. And then when we don't define a data field with static, that also means that data field is also an instance data field. So every time we create an object from a class, that object has its own copy of the instance fields, and those are separate from another instance object. So if I were to create two rectangle objects, one called kitchen and another one called bedroom, and another one called den, each one of these objects of kitchen, bedroom, and den, they all have their own length and width values inside of the object, and they're all separate from each other. And there is another convention that's quite pervasive in Java programming, and that is about the naming of data fields or data attributes and the naming of method names in the classes. So you can take a look at this link that's provided. So the name of a data field or data attribute is typically a noun like power level or width or length. And then the naming convention for method is typically a verb with a noun like store data, fetch pets, verify name. And you can also see that the method name is typically camel case, where the uh, first letter of the word is capitalized, except for the very first letter on the first word. And the same thing for data names. So the field names also have a similar naming convention. The first letter of each word is capitalized, except for the first letter. That is the proper I mean, that's the proper naming convention. And also capitalization for constants is where we do not, we typically do not put field names in all caps except for constants. And what you will see here in this example here is that you might see constants be defined like this. So public static final, and then putting a string name like constant string all in caps, and then using a underscore in between each word, that being the naming convention for string values or even numeric values that don't change at all. Okay. So here's a more visual representation of that the kitchen, bedroom, and den are all three variables, and then all of these three different variables point to three separate objects that have their own copy of the length and width values. Constructor is a very important concept within Java classes. This is the way that a class is then goes through the process of creating initializing some data instance fields within the object, and so that you can create an object from that class. There is a concept of about a default constructor. That default constructor um, uh, is something where the class doesn't have any parameters, and we'll see more of that. So the constructor has to have the same name of the class, and the constructor has no return type, and it cannot return any values. And the constructor are most of the time they're public. There's a few times that they're not public, but we're not going to talk about that right now. So when we create a constructor for the rectangle class, it might look something like this. The actual constructor, it might take the an input parameters of the length and the width as len and w, and then set those to the internal instance attributes of length and width within the object. And then you would see here, this is the way that you would put the constructor in the UML diagram. And then here, point noting is that there is no return type for the constructor. So you can define objects without being initialized like this. What it means is that there will be potentially values within the object box that are not initialized because the constructor hasn't been called yet. So between the line where rectangle box is defined and where the box equals new rectangle is specified, between those two lines, the box variable is not yet initialized. So it's very unwise to use that box variable between those two lines. So if you actually do try to use it before it is initialized, typically the compiler will give you an error.